Hello, everybody. Hello, guys. Okay. I'm just going to wait a couple of more minutes to see if more people are going to join. Okay. So we have about 5 or 6 people on, and I think I'm going to get started. Hi, everybody. My name is Kennedy Cheek. I'm a senior in high school, and I've been with NEED for about 2 years now. And today we are going to be talking about thermal energy, more specifically thermal energy with gas. We know what it does with solids. It kind of melts. We know what it does with liquids. It kind of bubbles up and boils, but we don't know what it does with gas. And today we are going to find out. So we have a balloon, and we're going to start by blowing it up, and then we are going to measure it. Get your measuring tape out. And we're going to measure the circumference. Can anybody tell me what the circumference means? You can drop it down in the comments. No, nobody knows what the circumference means? Well, the circumference is the distance around a circle or sphere, in this case, a sphere. So I'm going to take the largest point and measure it around. So it is 12 inches. So remember that number, 12 inches. And now we are going to get some ice water, which is here. And I'm going to add a few ice cubes and put it in the water. Okay. So now we have our ice water, and we are going to submerge the balloon in the water for about 1 minute. So I'm going to take this, use my handy dandy tongs here. Okay, so now we have our timer going. And while we wait, where are you guys tuning in from? You can drop it in the comments where you guys tuning in from. Thanks, Wendy. Oh, Mary said VA. Virginia. Okay. Near me. I'm in Maryland right now. Bowie, Maryland. Yeah. Oh, Indiana. We have Indiana. Okay. So I think we are about done. And now we are going to take it out and measure it again. So Get the measuring tape and measure it again. So, return. And now the circumference is about 11, a little bit over 11. So if you guys can see, a little bit over 11. And what happened? If you guys know. So the balloon decreased in size, and now we are going to see what happened when you put it in hot water. So I have my bowl, and then I'm going to get my hot water. I'm going to pour it out carefully. Okay. So since you see that it decreased in size when it went into the cold water, what happened? What do you think will happen when it goes into the hot water? Okay. So somebody said expand, get bigger. Okay, yeah. Okay, so let's test this out. Now we have our thermometer to make sure that it is hot enough for us to work with. And it should be around 180, close to boiling, but not quite there yet. And we are at about 180, so that's perfect temperature. So now we are going to reset our timer and dip the balloon in the water and start. Okay. Trying to get out, trying to pop out. Okay. Okay, so now my next question is, since we are in quarantine, what is you guys' favorite quarantine snack? So I know mine is ice cream. I've been eating a lot of ice cream over this quarantine. Okay, so I get you from what you can already tell it got noticeably bigger. So let's see how much bigger it got. So we're going to take ice cream, popcorn, yeah. So now we are going to take our measure. And it expanded to about 12 and a half to 13 inches. So, popcorn and potato chips, yeah. So it did expand to about 12 and a half inches, 13 inches. And now it's going back to size because now I was getting smaller because it's in room temperature now. So, what can we infer from this experiment? We saw that it decreased in the cold water and increased in the hot water. So, what does that mean? But do you guys have any guesses of why it does that? Nope. Okay. So when you have thermal energy is an energy source, and when you add it to the particles of my breath in the balloon, they start to speed up and try to push apart from each other. This is because this is like anything. You know, when you give a kid candy, they start running around, get all excited because they have sugar and energy in their system. But when the energy goes away, when you put it in the cold water and you take the heat away, the molecules start to slow down and compact towards each other. Like when the kids, after they get their candy and the sugar wears off, they get tired and they want to stay in one place and go to sleep. It's the same concept. Also, have you ever wondered why sidewalks have cracks in them? This is the same thing. When the weather gets hot, the materials, the concrete, and they start to expand in the summertime and contract in the wintertime. And this moving of the materials causes cracks in the concrete. And so does anybody have any questions so far? No questions? No? Okay. Thank you. Okay. So when it's just like when it happens in all of the forms of solids and liquids. When you heat up something, they expand and they get bigger. And when the molecules push farther apart and the solids becomes a liquid, and liquid, because solids are compact. They're compact and they don't move a lot. They buzz together, but they are compact. When you apply heat, they start to spread apart and and still moving a little bit, but they spread apart a little bit faster. And then gas, and then when you heat it up some more, it turns into a gas, which I don't know if you can see, but the water is giving off a vapor, like steam, and that is the energy turning gas. That is the thermal energy turning the water into gas. So now the particles are moving farther apart, and they're going really fast. They're going farther apart. So yeah. Okay, thank you for everybody that was tuning in. I appreciate the contribution, answering the questions, and listening to my experiment. Thank you, guys. All right. Thanks, Mary. All right. Bye, guys. All right. Okay.